I made what I think is a fairly bold claim in the last lecture, or at least bold as a claim an educator can make. We tend to be a fairly cowardly lot. But in terms of the bold claims that I do think I can make about logic, the claim that averting any standard form categorical statement will result in a new statement that is different but shares the same truth value as the original and communicates the same information and has the same thing as the original, that's a fairly bold claim. And you shouldn't just take my word for it that that's the case. You should say, prove it, dude. And that's what I'm going to do here in this lecture, is I'm going to prove obversion. So let's start with our A claim. We're working with the statement, all logic students are brainiacs. We apply the 2 steps of obversion to that claim to create the statement, no logic students are non-brainiacs. And to prove that those 2 statements have the same meaning and the same truth value, we're going to use a Venn diagram. So we're going to Venn diagram the first statement. All logic students are brainiacs, and we do that by shading in area 1 here. Because area 1 would be the area where there would be logic students who are outside the brainiacs circle. Okay? So remember, maybe think of these 2 circles, the red circle and the blue circle, as 2 buildings that we're looking down into from high above, and the roofs have been removed, and we're looking into these two areas where all of the logic students are and all of the brainiacs are. And area 1 has nothing in it because all the logic students are over here in the brainiacs area, area 2. And then area 3 would be people who are brainiacs but are not logic students. And then out here in area 4, which we haven't talked much about, these are the things that are not brainiacs and are not logic students, right? Because they're outside of both buildings. So the stuff out here in area 4 are going to be things like bicycles and bananas and caterpillars, anything that's not a logic student and not a brainiac. All right, so now we would ask this question. Here's our first question. If all of the logic students are in the red circle, where are the non-logic students? In other words, where are the things that are not included in the category logic students? And if you said, well, out there in area 4, bicycles are not brainiacs and bicycles are not logic students, so they'd be out here in area 4. Same things with bananas and caterpillars. Those are non-logic students, and caterpillars aren't brainiacs or logic students, so they'd be out here. So all the things that fit into this category non-logic students are going to be out there in area 4. There's one other place where we're going to find some non-logic students. Can you think of where it is? It's going to be in area 1, 2, 3, or 4, and we've already decided some of them are 4. And if you said there would be some non-logic students in area 3, you're a rock star. Yeah, totally. So think about this. The red wall here is confining all of the logic students inside this building. They're all right here in area 2. So anything out here is a non-logic student, but also anything over here in area 3 is a non-logic student, right? So if you have a carpenter who's a brainiac, if you have an astronomer, a physician, a designer of some kind, and they're all brainiacs, but they're not taking logic and not studying logic, they wouldn't be included in the logic student, but they would be included in the brainiac part of the circle here, or the diagram. And so we'd identify there's non-logic students here in area 3 and area 4. Now, where are all the non-brainiacs? They could have been some in area 1 because those would be logic students who are outside the brainiac circle, but we already shaded out area 1, so there's nothing there. So there's no non-brainiacs in this area of the Venn diagram. And there's no non-brainiacs right here in area 2 because those are by definition brainiacs. Same thing with area 3. By definition, anything in area 3 is a brainiac. So the only place the non-brainiacs are is out here in area 4. Okay? So now we got to look at this Venn diagram, and this is kind of the cool part. So we look at this diagram, we see that it represents all logic students are brainiacs. Does it also represent the statement no logic students are non-brainiacs? No logic students are non-brainiacs. And we'd say, yeah, it does, because all the logic students are right here in area 2, but there are no non-brainiacs there. Everything in area 2 is a brainiac, not a non-brainiac, but a brainiac. Okay, so this Venn diagram shows all logic students are brainiacs, and it shows that no logic students are non-brainiacs, okay, because there's none of them in area 2. So this proves that obversion works as I described on A statements. What about E statements? We had the statement no logic students are troglodytes, and we applied the 2 steps of obversion to create the statement all logic students are non-troglodytes. So again, we're going to create that Venn diagram to represent the first statement by shading out area 2. There's no overlap. There's no shared members between the logic student category and the troglodyte category. So we've got to turn out the lights in area 2 and leave because there's nothing there. No logic students are troglodytes. So now the question becomes, all right, again, and this is a useful thing for you to practice doing. Where are all the non-logic students? Okay, where are all of those people who are not logic students? Where are all the non-logic students? Okay, there's 2 places. They're in area 3 because that's where all the troglodytes are, and our statement asserts no logic students are troglodytes. Okay, so that means that all the non-logic students are right here in area 3. They're also out here, of course, in area 4 because you can see they're totally outside the logic student circle. Anything out here in area 4 wandering around in the field looking at the birds is a non-logic student. Similarly, all the non-troglodytes are here in area 1 because what the statement says is no logic students are troglodytes. There can't be any troglodytes here in area 1. Anything in area 1 is a logic student, and anything that's in area 1 is also a non-troglodyte because no logic students are troglodytes. Okay? And then finally, of course, we have our non-troglodytes out here roaming around in the fields. All right, so does this Venn diagram now show the statement, does it represent the statement, all logic students are non-troglodytes? And we say, well, yeah. All the logic students are here in area 1. There's no logic student anywhere else. Anything outside of the area 1 is a non-logic student. Okay, so there's some in area 3 and there's some out here in area 4. And anything here in area 1 is outside the troglodyte circle, so it's a non-troglodyte. So all the logic students are also non-troglodytes. All right, so if I can prove this again for I statements and O statements, and I'll go ahead and do this, but if you're sort of getting the idea and you're feeling fairly comfortable with this idea of the 4th area and putting the nons, the term complements in these different places, you don't have to watch the rest of this. But if you want more practice at how to identify where those term complements are, I'll try to wrap this up here in the next 4 minutes or so. All right, so proving obversion for I statements. Some logic students are credivores and some logic students are not non-credivores. Okay, so again, we create a Venn diagram for some logic students are credivores by putting an X right here in area 2. That shows there's at least one logic student that is included in the category of credivores. And then we place our nons around, right? So all of area 4 is going to have non-logic students, non-credivores, anything outside there in area 4, like a banana or a bicycle. That's not a logic, it's non-logic student and it's a non-credivore. Okay, and then of course we put all of our, in area 1, anything there is going to be a non-credivore because it's outside the blue walls of the credivore circle, and anything in area 3 is a non-logic student because it's outside the red building that's holding all of our logic students. Okay, now we ask ourselves, do I see the statement some logic students are not non-credivores? And it's like, yeah, we do. See this X right here? That shows us that there's at least one logic student that is a credivore. But we also see that there can't possibly be any non-credivores in area 2 because area 2 is included in the circle of credivores. All the credivores are within the blue circle. Okay, they're in the blue building. So anything in area 2 is by definition a credivore. So some logic students, namely this one represented by the X, are not non-credivores. Okay, so that proves obversion for an I statement. Let's wrap it up with proving it for an O statement. Some logic students are not Gaberlunzies, and we applied obversion to that statement to create the statement some logic students are non-Gaberlunzies. And again, we create our Venn diagram to represent the original statement some logic students, like this one right here in area 1. They are not Gaberlunzies. They're outside the Gaberlunzie building. And we go ahead and start placing all of our term complements around here, and we see that anything over here in area 1 is a non-Gaberlunzie because it's outside the walls of our Gaberlunzie building. Same thing with this guy out here in area 4. Same thing with the non-logic students. Anything that exists outside the red circle is by definition a non-logic student. So anything out here in area 4 like automobiles and bananas and so forth, that's a non-logic student. And those non-logic students are also over here in area 3 because they're outside the red building containing all the logic students. So now we ask ourselves this. Does this Venn diagram show the statement some logic students are non-Gaberlunzies? Look at that. Anything in area 1 is both a logic student and a non-Gaberlunzie. So it's true that some logic students are non-Gaberlunzie. This guy right here, he's a non-Gaberlunzie as well as being a logic student. All right? So that proves obversion. Okay? We obvert any standard form categorical statement. The new statement has the same meaning, communicates the same information, and has the same truth value as the original.